Welcome to the cardiovascular system. This system is studied in chapters 18 through 20. We start with blood. Blood is a connective tissue and it has multiple functions. We're constantly producing new blood because our blood works so hard that a lot of our cells die very rapidly. Some of the major functions of blood: transportation, regulation, and protection. And so we're going to look at those functions, and then we'll look at the characteristics associated with blood. If this changes. There we go. Okay, so what is blood composed of? There are three types of cell structures: erythrocytes, which are called red blood cells; leukocytes, which are your white blood cells; and then platelets, which are tiny little pieces of a larger blood cell known as a megakaryocyte. Erythrocytes function in transporting nutrients to our cells and getting rid of waste products. Leukocytes protect us from foreign invaders, and platelets protect us from bleeding out. The non-living component of blood is called the plasma. So this is the matrix of our blood connective tissue. And it's mainly composed of water with multiple solutes in it. So I mentioned the three basic functions are transportation, regulation, and protection. So I just threw this picture up just to show blood vessels. Transportation is one of the major functions of blood. It's kind of like the taxis for all of our nutrients. Blood sends nutrients to the cells that need it, and then takes the waste products out so that we can excrete them. And the roadways for blood are the blood vessels. And the hub, what makes it run, is the heart. So it's kind of like this whole system, transportation system. But blood also regulates body temperature. So remember last semester we did an activity where you had to exercise, and then during the exercise they were checking to see how hot you felt and if your face started to flush and stuff. And we looked at how or what was going on. Were you sweating? What was happening? Because blood helps to maintain body temperature. Our body temperature is about 37 degrees Celsius normally. If it starts to raise, that's going to cause blood to move the heat towards the surface of our skin, and then immediately the heat is going to cause or going to stimulate sweat glands, and sweat glands are going to release sweat, and we're going to sweat, and then the sweat evaporates, pulling that heat away. So it helps to regulate our body temperature. If we're really cold, blood will move away from our extremities and stay in the core area, keeping the core regions, the main organs of the body, functioning. Blood also helps in regulating body pH. Our pH has to be maintained at about, our blood pH has to be maintained at about 7.4. So we give it a 7.35 to 7.45. So 7.4 is like that perfect, set point area. And we're constantly converting molecules of carbon dioxide into carbonic acid, and which then can break down into bicarbonate and hydrogen ions. And then we can reverse this process so that we can help to maintain that blood pH. This is known as a carbonic acid bicarbonate buffer, which we talked about last semester in chapter 2. Blood also helps to regulate fluid balance. So the amount of protein in our blood actually I won't say pulls, is going to influence the amount of fluid that comes back into the blood. So we're constantly exchanging nutrients from the blood to our cells, from the cells to our blood. But most of the fluid gets pulled back in because we have a lot of proteins in our blood that helps to pull those fluids back in to maintain that blood pressure and fluid balance. The last major function is protection, and so I put this cute picture here. Here's a white blood cell. Here's some type of a pathogen. Who knows what it is? It could be whatever you want it to be. And there's a bunch of red blood cells that can't defend themselves because their function is to transport nutrients behind him. So white blood cells, or leukocytes, function to protect us from multiple pathogens. Platelets help to protect us from bleeding out. So both of these are protective structures or protective cell types. Depending on the exact white blood cell, we'll be talking, or they do have slightly different functions. So most of our white blood cells are nonspecific, but we do have a couple that are specific. They only fight off one type of invader, and they do it really, really well. And that we'll talk about when we get into the immune system in chapter 22. So blood has a specific color. It's red. Blood is always red. Even when you see it, your veins look like this bluish color. It's still red inside. It doesn't turn red when oxygen hits it. It's always red. The amount or the deepness of the red is going to influence how, or is going to be influenced by how much oxygen is in the blood. So oxygen-rich blood is going to be very bright red. Oxygen-poor blood is going to be very dark in a color. And in general, we have between 4 and 6 liters of blood in our body. So we typically say 5 liters. And what you can think about, you get a 2-liter bottle of Coke. If you take 2 of those, that can be the full amount of blood that's circulating in your body at any given time. That's not a lot of fluid, really. Males tend to have more blood, and there's reasons for this. Males are larger, so they need more blood. Males also have more testosterone, so they produce more blood for that reasons. Blood is thicker than water. You've heard it before, but it's true. It really is thicker than water. If you pour blood and water, blood is going to be thicker. It's going to fall to the bottom. Water would stay up top. The thickness of blood is going to be associated with the amount of proteins and other solutes that is in the blood. So if you have a lot of cells in the blood, then you're going to have thicker blood. If you have very few cells in the blood, you're going to have thinner blood. If you have a lot of protein in the blood plasma, you'll have thicker blood again. Make sense? Blood plasma is predominantly composed of water, and then it has some dissolved solutes in them. So the solutes that are in the blood plasma are things like proteins, hormones, ions, sodium, chloride ions, as well as other carbon dioxide, other molecules that dissolve in the blood plasma. And the temperature of blood is typically slightly higher than body temperature. So as it moves through our organs, it actually warms those organs up. Blood's pH is about 7.35 to 7.45, and it is maintained very well using different buffer systems, as well as the respiratory system and the urinary system help in functioning, help our blood maintain its pH functions. If we take blood and we centrifuge it, so that's what this little machine is, spins the blood really fast, larger material will settle out at the bottom and the lighter material will be at the top. And so when we centrifuge it, this is what blood looks like, and you can see the breakdown. What the plasma makes up about 55% of our blood, and it's mainly composed of water with a bunch of different proteins and other potential materials. So these differ depending. Our platelets and white blood cells make up this tiny little region called the buffy coat. So all of our immunity and protection from pathogens is in this little tiny buffy coat. And then 44% of our blood is composed of white or red blood cells. And the number of red blood cells is known as the hematocrit. So I just mentioned this. I'll show you this slide. You can kind of look at it, and now I'm going to go over here. The hematocrit is then has two different definitions. Clinically, a hematocrit is the percentage of red blood cells. If you're not looking at in a medical setting, the hematocrit is just the percentage of formed elements. Males tend to have a higher hematocrit than females, partly because males have testosterone, and testosterone causes more blood to be produced, more red blood cells to be produced. Also, females tend to lose blood every month during our menstrual cycles. Blood plasma, I mentioned this, is composed mainly of water, but there are dissolved proteins and other molecules. The plasma is your fluid matrix. It's your extracellular fluid, and it's very similar in composition to interstitial fluids, but it typically has a higher concentration of proteins than interstitial fluid has, which is important because that way we can pull fluids back in. So blood has a lot of proteins, so it's considered a colloid. And that means that it can exert a certain amount of colloid osmotic pressure to pull fluids back in. Here are some of the proteins that are found in blood. So we have albumin, globulins, fibrinogens, which work in clotting, clotting proteins, which work in clotting, other enzymes, as well as hormones. And so this is a figure that I found off of Google Images. I thought it was really cool because it kind of shows the red blood cells. It shows white blood cells. And, I thought there was going to be something else on there. Sorry. My fault. But it's a really pretty picture. For some reason, I thought there was something else going to come up. Albumins are some of the smallest proteins, but they are very abundant, and they're important because they contribute very greatly to the colloid osmotic pressure in our blood, which we're going to talk about in a few minutes. Globulins, these are your antibodies, which are produced by your B lymphocytes. And then fibrinogens, these are the precursors to the fibrin threads that form blood clots. I'm going to stop here because my time's almost up, and then I'll get right back into it in a little bit. Enjoy the rest of the day or evening, whatever time it is for you, and I hope you enjoyed this lecture. Bye!